All right. Remember I told you that there were two different methods for dividing with polynomials. The first one was long division. The reason we learned a long division is because it's always going to work. The second method is synthetic division. It is the shortcut. You're going to love doing synthetic division once you catch the hang of it. It'll take you about three of these problems. Once you see those three, you'll be rolling through this like a champ, hopefully. Before we get into it, just want to remind you of some of the words and terminology we're going to be using interchangeably. Remember that roots, x-intercepts, zeros, and solutions all mean the same thing. So when we say those words, just know it's all the same thing. It just means you put a zero where the y is and solve. So if I ask you for the root of this polynomial, you'd put a zero on that side and move the plus 3 over, it'd be a negative 3. So the root of this is negative 3. The root for this one, hopefully you're seeing the shortcut, is always just change the sign of the last number and divide by the front number. If you can't see that though, you can always set it equal to 0 and solve. So x is 3/4 is the 0 for g of x. So that's how you find the roots if there's no exponents, or if the exponent's a 1, that's how you find the roots for the polynomial. Quadratics, you do quadratic formula, factoring, completing the square, any of those. But right now we're not trying to even do solving. Right now we're just doing synthetic division. The problem is going to look very similar to long division in the way that it's written, because it's the same exact problem. I could do this problem using long division, put the x minus 4 up front, and then put these numbers under the division bar and then go to town with it. But I'm going to teach you synthetic division, and here's the rules. And you're going to learn this setup. Once you do it a couple of times, you'll have no problem with it. When I am doing this problem using synthetic division, I'm going to find out what makes this back one, the one I'm dividing by, what is the root of that polynomial. In other words, what can I put in place of the x to make that parentheses 0? And that would be a 4. So I'd put a 4 in the box. The numbers in the coefficients, the numbers in the polynomial I'm dividing into, go in a line this way. So it's an understood 1, 3, and negative 8. If I'm missing a term, like if I have an x to the 4th and an x to the 3rd, but I'm missing an x squared, I do have to put a 0 in that spot in the order. We'll see an example like that. But the next thing I do is skip a space and then draw a line. And I've got the problem set up, ready to go. Here's how synthetic division always works. Always drop the front coefficient below the line. Then anything below the line gets multiplied times the box for the next column. So it's going to be 1 times 4 is 4, and then add the column. Anything below the line gets multiplied times the box for the next column and add. And now that I'm out of numbers, I put a box around that one, I'm done. Now I just have to write my answer. Here's how you write the answer. The answer is going to come below the line. So these numbers below the line are going to go in there. And the rule is, since this is an x to the second, you always take what you're dividing into and subtract 1 from the exponent and put this number in front of that. So it's going to be, this was x squared, so this would go in front of x to the first. So it's going to be 1x to the first, which is just x. And then count down from there. That has x to the first, this has no x. And the number in the box is going to be your remainder, which you write over what you are dividing by. Now the problem with number 1, I hate starting off with this problem, but they tell us to. I hate starting off with this problem because it's so short and so simple that it's very difficult to actually see the pattern very well. So we'll go ahead and start this next one. The way you do this is you always start off with the root of the back number, of the back polynomial, goes in the box. Then write the coefficients in order next to it. Skip a line, draw a line, and now you're set up, ready to go. Always start by dropping the front coefficient below the line. Anything below the line gets multiplied times the box for the next column, and add that column. Anything below the line gets multiplied times the box. It gives you 14. Add, it gives you 21. And 21 times negative 2 is, times negative 2 is negative 42. And add those columns, it gives you a negative 54. So that right there is the answer. I just have to write it in the correct form. Here's how you write it. Since the highest exponent was a 3, this goes in front of x to the 2, or x squared. So it's going to be 1x squared minus 7x. That goes in front of x to the 2. That goes in front of x to the 1. That goes in front of just no x. It's the constant. And then my remainder goes over what I was dividing by. You can either put the negative in front of the fraction like that, or you can write a plus sign and put the negative up there with it. Both of them mean the same thing. That is your answer. That's synthetic division. Very quickly. Now the problem with synthetic division is it doesn't always work. That's why it's a shortcut. Shortcuts always are shorter and easier, but the problem with shortcuts are they don't always work, or else it wouldn't be a shortcut, it'd just be the way to do the problem. So let's go through it again. Let's do this problem here. Always take the root of the parentheses in the back. What can you put in for x to make that 0? That would be -1. Don't forget I have an x to the 4th, but I'm missing the x to the 3rd. So I need to put a 0 in that spot. So I take the coefficient of x to the 4th. I'm missing x to the 3rd. -8's in front of x squared, 1's in front of x, and -10 is the constant. Skip a line, draw a line. I am set up, ready to roll. Now, the way this works is always take the front coefficient and drop it below the line to start the process. Anything below the line gets multiplied times the box for the next column. -1 times -1 is 1, and add the columns. -7 times -1 is 7, add the columns. 8 times -1 is -8, and add gives you a -18. Since this was x to the 4th, that goes in front of x to the 3rd. So it's 1x to the 3rd minus 1x squared minus 7x plus 8, and my remainder goes over what I was dividing by. And there's my answer. Hopefully you're seeing how to do this. If you need to, you can always pause, rewind, whatever. If you need to see it again, we're going to move forward to the next problem. Process stays the same. We're fixing to see a problem that doesn't work with synthetic division. We'll show you why in just a moment, but let's make sure you've got this type of work down. You may even want to just copy this problem down and then press pause and then try to do it yourself. And then you can let me play it or play me and let me show you if you got it right or not. But to do the root of this right here, you find out what goes in place of the x. To make that 0, that'd be a +3. Then write them down in order. Make sure if anything skipped, you put a 0 in that spot. I've got a 1x to the 5th, 0x to the 4th, 3x to the 3rd, 2x squared, -6x, and a +25. Skip a line, draw a line. Drop the 1 and begin. 1 times 3 and add. 3 times 3 is 9 and add. 12 times 3 is 36 and add. 38 times 3 is 114? Nope. Yeah, 114. And add. 108 times 3 is 324 and add. Now, you may be thinking, oh my goodness, these are some big numbers. But think about having to do this doing long division. If you had to put the x minus 3 in front of the box and put that whole thing in that side of that divisor, and you get towards the end, you're having to multiply by 108 on the top, distribute it out, and subtract it all. This is so much shorter. It's not the problem's fault that these numbers turned out big, or the method. It's just this problem. Since this starts off as x to the 5th, that goes in front of x to the 4th. So it's 1x to the 4th plus 3x to the 3rd plus 12x squared plus 38x plus 108. I can't write. And my remainder goes over what I was dividing by. So there's your problem. Or there's your answer. Any questions about that?